we'll be starting our next presentation. It's a presentation by Sasha. The title is The Three Unfunded Pillars of Digital Business. Please.
Hi, everyone. Thanks so much for coming here. Always raise your hand if there's any questions or any comments that you have. I do have a lot of content and a lot of ideas. I do hope that it doesn't get lost in translation. But thank you so much, and I hope we can have a conversation either here or maybe in open spaces after. So I'm talking today about the three unfunded pillars of digital business, and I wanted to start by introduction. So my name is Sasha Rosenbaum. You might find me on Twitter as Divine Ops, increasingly switching to using LinkedIn. I've been in the industry for about 20 years. I've worked for some companies you may have heard of. I've actually helped organize DevOps Day Chicago since 2015. So I love DevOps Days events and I feel at home. This is basically my first time in Tokyo. It's very exciting. The sushi is great, obviously. The beef is even better somehow. I didn't expect that. And I've recently started a consulting company with two other people who are somewhat famous in DevOps, I guess. So Andrew Clay Schaefer and Jay Bloom, you may have met them before. Andrew is credited with inventing the word DevOps. I know Patrick is on Wikipedia, as a father of DevOps, but Andrew is the first person who tweeted the word. So we have the first person on record mentioning the word DevOps. Anyway, so Andrew has been talking for many, many years, 15 years now, about the wall of confusion between the dev and ops, right? Because dev pushes for innovation and ops pushes for stability. And so we have this core conflict in between them. And we have improved the industry tremendously in the last 10 to 15 years, but the core conflict is still there. So if we talk about all the things that go into our business, there's a lot of things that are foundational to building good quality software and to shipping digital software and making your business successful. And I'm not saying that the three pillars I'm talking about are the only things that are important, but they tend to be the things that are kind of difficult to get funded, right? So if we look at the elephants that everything is based on, like I'm thinking that innovation is the thing that we always have an easy time funding, and some other things tend to be difficult. Now, you may notice that some of my slides are AI generated, and if you look closely, these elephants don't have the correct number of trunks, and that's a little bit representative of the state of AI accuracy when you're asking it simple questions. So innovation is a thing that, like, usually if you show up to your CEO or CIO or CTO and you ask for money for innovation, you'll have an easier time finding it. So by innovation, I mean many different things, right? So new features, just like something that differentiate your application to the consumer, like some groundbreaking innovation. So yes, I've created a new subset of features or industry, or invented a chat GPT or something like that, as well as some things that are just very hyped at the moment. So like at the moment, right now, every C-level person in the industry has been tasked with doing some sort of AI-powered transformation. And so in many cases, this just results in people rubbing AI on whatever they're doing without necessarily providing any benefits. But this happened many, many times before. So like 10 years ago, it was all about big data. At some point, we all did a DevOps transformation. At some point, we all did an agile transformation. People talked about continuous delivery or IoT or serverless. And by and large, a lot of these things become fashionable and then become retired. And some of them just don't make any changes in the industry. Some of them make changes in the industry that are positive, but kind of then lose the momentum. And some of them just become technical debt because they're sort of half implemented and then the company moves on. So this leads me to a question of, is AI winter coming? Anyone familiar with the concept of AI winter? 3 hands, 4 hands, cool. So AI winter is when you have a very, when you have a breakthrough in AI field, and this has happened in a few previous decades, and you have lots of investment because people get very excited about AI. And then because like you sort of essentially hit the wall at some point, you get limited investments. And so this doesn't represent the fact that AI got worse. It represents the fact that we got overly excited and then we come like down from the hype, right? So I'm basically asking a question at the moment. Are we going to face exponential investment, or are we going to face another AI winter? So I don't know. Let's talk about it in 3 years and see how your like AI implementations inside your businesses are going. So again, the 3 pillars are not the only thing that are crucial to creating successful digital business. These are the things that, for whatever reason, and we're going to talk about reasons some more, tend to be difficult to get funding for. So the 3 pillars that I perceive them are technical excellence, platform engineering, and reliability. So let's dive into each pillar and see a little bit more detail about the pillar itself and its funding. So the technical excellence to me is basically the opposite of technical debt, right? So that's when you actively invest in making your software as good as it can be and doing maintenance, improving your code, and like actually doing that as you go. So my little hot take for today is that essentially all code is technical debt. So because the moment you've written your code, the universe had changed. And so basically you might have new things available to you that weren't before. So if we look at the definition of technical debt that most of our industry uses today, it's about creating shortcuts. So like making poor design decisions and implementing something that's subpar. But the original definition of the guy who, Ward Cunningham, who coined the word technical debt, is the difference between design that it is that you have today and the design that would be right now if you knew all the information that is available to you right now, right? So it's not about necessarily taking shortcuts, but it's about realizing new information. In my opinion, there's 3 types of technical debt. There's poor decisions, there's code age, and there's the changes in requirements. So the poor decisions, I came across this quote like last year, and it's in the book called Everybody Writes, and it's about writing. But the quote is, there's no one way to write, just as there is no one way to parent a child or roast a turkey, but there are terrible ways to do all 3. So to me, this is like very applicable to software. There's no one right way to write software. Like even if you read all the books about patterns and design and whatever, you wouldn't never be able to design perfect software, but you can certainly make really poor decisions and create terrible software. Now, code age is like, in my opinion, so I'm using this example, and I don't know if it's ideal, but it's one that people are familiar with. So Equifax got hacked through a vulnerability in Apache struts. That was, so basically what happened was a vulnerability in essentially an open source package was found in March. And companies were not notified about the vulnerability and asked to patch it within a couple of days. That didn't happen. And so in May that same year, so a couple months later, the Equifax got hacked through the same vulnerability. Now, this to me, so the poor decision here was not to remediate the vulnerability once you knew about it, but I'm talking about in terms of code age, because when they implemented the solution, there was nothing wrong with it, right? And then someone discovered a vulnerability in an open source package, and overnight this code became inefficient and subpar and vulnerable to breakings, right? So if you implemented your code as best you could and never touched it again, you would have a problem just like a human organism tends to deteriorate with age, the same happens to our code. And then the next thing is, so this is Nokia 3310. Anyone here had this phone? Oh, I don't know what happened. This is cool. It's all right. I presume some button was pressed. So if we were struggling for time before, we're struggling for time now. Oh, this is even worse. Great. Technical difficulties. Bear with me. That's better. All right. Anyone here had this phone? Yes. Anyone thought it was amazing? I mean, I certainly did. Anyone would want to have this now instead of your iPhone or Android? No hand. 2 people. Oh my God. But in any case, this is just like, even if you really wanted to, you'd be really hard to function, right? Just because it's too old and because your requirements have changed and your understanding of technology and our needs with technology have changed, right? So the world has changed. And this is technical that, like, if you try to use this phone today, you would just not be able to function. So this is something we understand with hardware, right? When your company purchases a car or a truck or a van or a piece of equipment, machinery, then they know that it will depreciate over time, that you will have to provide maintenance, and that eventually will be retired and potentially sold for parts and for no money, right? But we don't do this for software. Sometimes we do this for third-party software, but it's very rare to see depreciation graphs for software. And this is very strange, right? Because sometimes we have like these code bases that are 40 years old, and then you say, hey, I need to, do maintenance on my code base, and your C-level executive goes like, well, why didn't you implement it perfectly the first time? Because it was different. Like, the world was different, the requirements were different, my ability was different, the underlying infrastructure was different, everything, right? So it just, the terrible pun for this section is software is not forever. Let's switch to the second pillar, and that's platform engineering. So like, platform engineering is this cool new trend that a lot of people are talking about, and everybody's like, oh my God, we invented this new thing, it's platform engineering. I think this is not a new trend, and I think that everyone in DevOps was essentially doing platform engineering from the get-go, because how are you supposed to implement DevOps if you don't have any kind of platform? So everyone wants to ship software, but a lot of people don't have a solution for platform underlying the software, and some people don't even have a solution for infrastructure underlying the platform, underlying the software. Now, it doesn't help that these terms are squishy. And so, like, say if you're in the cloud, then your cloud is your infrastructure, and the platform as a service is your platform. And then on top of that, you have your in-home platform. And then on top of that, you have your software. But if you're on-prem, the delineation between platform and infrastructure could be more squishy. But in general, all of this is software, right? And all of this requires its separate dev and ops cycles, and all of this has separate development life cycles. And so there's this famous quote that comes from Werner Vogels, who was a CTO at Amazon. I think is still a CTO at some part of Amazon. And he said, the traditional model is that you take your software to the wall that separate development and operations and throw it over the wall and forget about it. Not in Amazon, you build it, you run it. This brings developers into contact with day-to-day operation of their software. So this often gets quoted as you build it, you run it. And so everyone's like, oh, you build it, you run it. That means that my developers now need to run their own stuff. So that's why we moved them to Kubernetes, and they're now doing the DevOps and operations for their software and whatever. So in big organizations, Werner meant developers run the software, not the platform, not the infrastructure, not the things underneath your differentiation layer, but the thing that provides your business differentiation. And so one of the things that is important, I think, for us to understand is that you always need a platform. You can't just show up and buy platform unless you're running a static website or like some very specific common use case. You can't just show up and buy a platform from a cloud and be done with it, right? You have to implement the platform that takes care of your own cross-cutting concerns inside your organization that are very specific, that correspond to your requirements. And then the second thing is that your platform may actually be made of people. So there's this old movies like Soylent Green and Soylent's made of people, and they realize that, like, if you think that you don't actually have a platform and you think that you don't have an internal API that provides you a service, then more likely than not, your API is a service now, and your brand. Raise a hand if you know who Brent is. Raise a hand if you read the Phoenix Project. Okay, so in the Phoenix Project that used to be really, really popular in this industry 10 years ago, there is a guy called Brent who is an operations person who knows everything and knows how to operate everything and solve everybody's problems. And the problem with Brent is that everybody wants Brent to work on their problem because they know that Brent is really good, and therefore Brent is super overworked and is completely unproductive and miserable. So in this context, basically, if you think you don't have a platform and you have no internal APIs, no internal implementation, that most likely you have a ServiceNow or some similar software doing ticketing, and Brent or your ops people are actually doing the backend service on that API. And that doesn't usually mean anything good for Brent. But then I'm going to make a joke no one will probably understand, but one must imagine Brent happy. So in the words of Albert Camus, the Sisyphus was happy because he was having intrinsic satisfaction from his work. And so, you know, the ops hero person that is doing all this work behind the scenes is probably getting intrinsic satisfaction from his work. So one of the problems people have with platforms and platform engineering and implementation is that they get funding from, you know, engineering to build a platform. They go into the bunker and build a platform, and then no one wants to use it. And so basically you have this push and pull where developers want to build their own sort of cross-cutting and shared services and implement their own shadow platforms. And on the other hand, you have the platform engineering team that is trying to essentially sell the platform to people and is unsuccessful at that. And so that's one of the challenges you have with platform. And then, sorry. And then so basically the two challenges are that you build a platform nobody needs while not building a platform that people do need. And the second part is you don't have a platform, you just have people holding the fort. Third unfunded pillar here is reliability. And so reliability is essentially availability plus stability plus quality plus some other ilities. So if availability is your uptime, how much your service is available, then reliability means that your service is actually doing what its users expect it to do. So it's, you know, reliability is availability plus plus. So the thing about reliability is that we have this trend of rising expectations. So if we went back to essentially the 90s, this type of downtime was extremely common in the 90s, right? You could take your website offline and you could work on it for a couple of days and you can remediate your problems. And then today, so this is from one of the Amazon services, and it says that if you have less than 95% availability, so essentially more than 1.5 days monthly downtime, you'll get 100% refund. So we went from the expectation that 2 days of maintenance was normal to the expectation that we're measuring maintenance in minutes, monthly minutes at the best case scenario. But the other thing that changed is that we used to ship software on CDs. So I used to let's say Microsoft used to build Exchange and then ship it to people. And then from the moment that it shipped the Exchange server to people, it was the people's own problem to run the software, to configure the software, to maintain the software, to be responsible for the uptime of the software. So essentially, the biggest organizations on the planet probably ran an email server for a couple thousand people. Whereas now, if you run Gmail, you're running it for billions of users, right? So your scale is completely different for some of these SaaS services. So in big organizations, your site reliability engineering SRE was born out of necessity. We didn't like create SRE because we hired software developers into operations or whatever. It's just that the expectation used to be relatively low, and then it became impossible to throw more people at the problem. So we had to implement automation to make it available. So the goal of SRE proper is not to take toil away from software engineering, is to drive toil out of the system. So you're not saying that I'm going to make my developers happy by making my ops handle all their business. You're saying that I'm actually going to take things that are painful and I'm going to implement them. So this is one of the quotes from the SRE book, and it's essentially saying that SRE builds framework modules to implement canonical solutions for the concerned production area. As a result, development teams can focus on business logic because the framework already takes care of the correct infrastructure use. So if you look closely at this quote, it says that SRE implements, basically takes care of the framework concerns, essentially takes care of the platform. So SRE is sort of married to the platform and enables development teams by taking care of the platform. So unfortunately for all of us, words cross the chasm of this understanding before practice. So in many organizations, what happened is that this team used to be support or sysadmins, and it was renamed to operations, and then it was renamed to DevOps, and then it was renamed to SRE, and now it's being renamed to platform engineering, maybe renamed to something else later. But in general, the practices didn't actually change. And so like people are doing the exact same thing, despite the fact that they are assigning different names to the team. So it's as if like we all used to drive this clunky old car and we like fixed it up ourselves on the weekend. And now we're like, okay, we're all going to do Formula One, right? And we're going to compete in this race. And except like it's the same car, it's the same team, and no one gave us any type of training budget or a new understanding, right? So like the expectations rose, but our ability to do things was exactly the same. And in other words, in the words of Andrew Clay Schaefer, my co-founder, everyone wants DevOps. Well, actually, what they really want is reliability, availability, scalability, operability, usability, observability, accessibility, all for free and without changing anything. And just to make sure we're on the same page, without changing anything. Seriously, like I mean this, without changing anything. So SRE isn't actually free, and you can't get it by, pretending to do SRE. So the problem with the chasm is when you have the innovators, they come up with a new practice because they're seeking advantage. And then the early adopters adopt the practice because they're seeking advantage. But then there's this chasm in the technology adoption lifecycle. And then most other people just show up to the party and say, oh, I just want to legitimize myself, right? So now instead of, again, changing the SRE practice, I am just saying that my team is called SRE. This creates an additional problem. So it's actually a double bite. Not only did you not implement SRE practices, you actually can no longer implement SRE practices because you say you already did, right? So all of these transformations are like this cyclical thing, because if I said I implemented DevOps 2 years ago, I can no longer implement DevOps. Now I can go implement, I don't know, continuous delivery. That doesn't even make sense. But like, If I already had a cloud transformation, now I have to have a serverless transformation, and then I have to have a Kubernetes transformation, and then I have to have an AI transformation, and all of these things, right? Because I have to get the funding. Go ahead.
Oh, let me repeat my questions for the translators. So I've seen that happen of the going in circles with the different transformations, and the way out of that is, rather than like transformation, instead have continuous improvement, because continuous improvement, unlike a transformation, isn't something that you can say you already did because it's continuous. Do you think that makes sense? Or
So it does, except in budgeting sense, right? Because in the budgeting sense, when I'm trying to convince a C-level to give me money for something, I usually have to provide some type of big banner and say, I'm implementing X. And so I've actually had conversations with actual real life directors or VPs of engineering or whatever, who would say, I don't actually care about this microservices thing, but this is the only way I can get money to do the things I need to do in terms of technical debt, right? So that's just a like sort of circumventing the funding problems. So I'm going to take digression and introduce you to a different concept. So we were talking about tech, and now we're going to talk about governance. So bear with me because it's a little bit academic. But so there's basically three primary forms of governance: resource governance. And if you think about like your country or your community, you probably can think of examples of two of them very easily. So private ownership, so property can be privately owned, right? And then like resources can be centrally planned. So you can have, government central plan, something like a public park or something like that. And then between them, in the squishy middle, there is something called commons. And commons are resources that belong to the community and are governed by the community. So the common example for this is something like a pasture or a lake. So let's say there's a lake and everybody fishes at the lake and everybody benefits from fishing at the lake. And the lake belongs to nobody. It's a common resource, right? But then let's say there is someone who shows up and fishes all the fish, right? So now everybody's starving because someone abused their ability to use the commons resources. This is known as the tragedy of the commons. And so the proposed solution to that is to switch to other forms of governance. So either central planning or privatization, because supposedly humans are not good at governing commons resources. Now, if you think about technology, in technology, you have open source as a primary example of commons. And so we've been trying to basically prove that we're good at governing commons. Recent examples of converting licenses notwithstanding, right? But like actually for certain, neither of these forms of governance is good or, I'm trying to get here. Neither of these forms of governance are good or bad, but certain resources do better if they're governed in one of these forms of governance. And certain things like, for instance, public data, in certain cases of public data, is better belonging to the commons than, say, being centrally planned or being privately owned, right? So commons are in the squishy middle, and governing community is part of the commons itself. So this is a quote from Dimitri Onufova, oh my God, that it has done a lot of academic studying of this concept. But here he says that the community governing the commons is essentially part of the commons, not just the lake, but the community who decides who's a violator, who should be, not permitted to fish. So if we take this a little bit further, Jay Blue, my co-founder, coined the concept of three economies. And so in our opinion, there is so economy is a system that governs converting resources into value. And so often we approach this saying everything in our company is governed by the same logic, but it isn't actually true. If you look closely, then developers belong to one part of this. So developers belong to differentiation economy, and differentiation economy, I want to get more customers, I want to enter new markets, and I want to do things differently. I want to innovate, I want to increase variation. And that operations usually belongs to the scale economy, which is control consumption, like use cost savings, use best practices, and do the same things repeatedly. So this is the core of DevOps conflict, right? Like we don't understand each other because we're actually driven by different interests. And so what we are saying is that in between those things, there, like this is the wall of confusion, but actually to be successful in this, we actually need to introduce a third part of the organization that sort of reconciles the conflict between the two opposing sides. And that's the concept of scope economy. So kind of similar to the concept of commons, the scope economy connects the differentiation and scale to enable innovation and efficiency. So it arises from ongoing negotiation between selfish interests in favor of the collective. Yes.
Well, first of all, thank you, because that's very insightful. It got me thinking, like that's very important, of course. But how do you sort of measure productivity in that middle part?
That's the problem.
Because it seems a lot less straightforward than with the either sides.
That's 100% what the problem is. So the postulate, and this is further in the slides, but the postulate is that 3 unfunded pillars are hard to get funded because they all belong to the scope economy. So essentially, it's easy to set targets when you know that you're going for innovation. It's easy to set targets when you know that you're going for cost cutting. But it's hard to set a meaningful target if you're in a squishy part in between that has to cater to both sides. So I'm switching a little bit, and we're going to start running out of time. But so in terms, like, I want to talk about the things that don't quite work for funding the unfunded pillars. So there's, like, you know, if this was easy, everyone would be doing it. So there's no easy answers. I cannot come in and say, to remediate technical debt, you just need to do this simple trick. Doesn't work. It's usually hard. But so, like, if you're talking about technical excellence, so one of the things that happens is we were just talking about yesterday at speaker dinner, but essentially, like, you have all these tools that come in, and like you run this tool on your code and it says that you have 60,000 vulnerabilities, or you have 4,000 years of technical debt, and that's a real example from somewhere. And then essentially what happens here is that it all gets blanket ignored because you cannot consume this type of information. If you are in this, like, everything's on fire situation, it's very, very difficult to actually convince someone to do something about it usefully. So usually people do blanket ignore most of it and then try to fix a really small part. The second thing that surprisingly doesn't work is a scary story. So, like, you can come into your executives and say, you know, we have all these vulnerabilities or whatever, and we're going to get breached, and, you know, we're going to lose millions of dollars and whatever. And usually this doesn't work because people psychologically don't want this information. And sometimes people legally don't want this information because sometimes your executive will go to jail if the breach happens. And so sometimes they can claim ignorance to not go to jail if the breach happens. So they actually don't want to listen to you talking about these things. And then the other thing that tends not to work is if you show up to your executive and you say, we need to rewrite this software and we need like 20 developers in 2 years, and we estimated that we can, you know, implement a new version. It's usually not a plan that's going to work. Now, there's some solutions that tend to work a little bit. So there are things in terms of technical debt that try to hone in on certain spots. So like Adam Thornhill has a tool that hones in on hotspots in your code based on things that change a lot. So basically you look at your GitHub and you try to find the spots in the code that change constantly. And that allows you to hone in on things that are problematic. Probably more interestingly, like you could look at the code that executes a lot to see what actually happens. But these are helpful because they allow you to focus, but at the same time, maybe your biggest bug is in the code that never gets executed, and then it gets executed once in 4 years and you lose $5 million because you're a hedge fund that's trading something on stock. I don't know. You can tie a specific technical debt problem to revenue loss. So like you have an internal application that you can show that people are like struggling with, burning a lot of time or making a lot of mistakes, having reputational damage, stuff like that. And then I've seen this work like you can ask for a percentage of time. So you say, I'm planning my sprints to do these new things, and then we need to do this maintenance. And like 10% of time every sprint goes towards doing maintenance. The problem with that is if you have a time crunch for any reason, then this immediately gets canceled and you get back into everything's new features. For funding new platform, again, what I see a lot in our industry is that like you have this platform team that gets funding at some point, and then like they try to implement a platform, and then you have a platform nobody uses, and you have people struggling without a platform. And then again, funding by engineering. So that's actually what people did at Google, but there are certain dynamics that you need to be able to implement this. Usually, if you try to fund the platform by the product teams themselves, the funding will get cut in favor of new features, right? Because if you're asking the product manager to decide if they want to give money to the platform or want to give money to their new fancy feature, they're going to choose the feature. And then funding and reliability. One of the things that enterprises do a lot these days is they talk about developer autonomy and productivity, and they say, you know, you can implement your app in whatever language you want. And like, let's make developers happy by letting them add all this variation. And that tends to backfire for operations because operations get all these different applications implemented in different patterns, in different languages, on different tech stacks, and they somehow need to manage it all and keep it all up. So again, that's a problem for operations. So the challenge, and you know, I said this in sort of answer to your question, but the challenge here is that the 3 pillars belong to the scope economy, which means that it's very difficult to set meaningful targets for them. So if the scope economy emerges from this ongoing negotiation in the middle of selfish interests, trying to reconcile favor of the collective, then to set meaningful targets, we need to be able to talk about that compromise. So the best example of this that I can give that like sort of is already part of a discussion is that reliability example. So if you look at, I'm not going to dive into service level objectives because I simply don't have time. It's a whole like 2 hours of conversation and so on. But if you look at the resources such as the Google books and Alex Hidalgo's book, Implementing Service Level Objectives, SLO is a service level objective target that is about reconciling the two sides. So let's say if you have a service level objective of 99.95, again, this is tied to availability, so it gets confusing as well. But let's say your uptime objective is 99.95, which means you have an error budget of 0.5, right? This means that if I reach my error budget, I have to stop my development. So SLO is a reliability target that represents an agreement between all of these different factions. So business development and operations. If I was striving for complete innovation, if I wanted to be differentiating as much as possible, I'd go for 100% availability, right? Because like I want to be as good as possible. I want to be infinitely available. If I wanted to cut costs as much as possible, I go for as little availability as possible. So when you set your SLO, if you actually are able to set your SLO, you set your SLO to what business can agree with you that is enough, good enough, right? And so like to set the SLO in the first place, you have to have this big negotiation between different teams that agree on what the actual enough is. And then the other thing that's important about SLOs is if you're not empowered to actually stop development when you blow your error budgets, then all of this doesn't matter. Like if your availability is supposedly 99, 95, but when you blow this and you're down for more than that, and you show up and you say, I need to stop development and invest in my technical debt, and your product manager is like, haha, no, we're doing new features, then you didn't really implement it. So targets are only as meaningful as the empowerment of the team to adhere to the targets. So I'm going to just kind of say very abbreviated, like in terms of technical excellence, I think the way to strive for this is to set balanced targets. So instead of just having targets around throughput, so like how fast we're going, you need to also set targets about quality and responsiveness and predictability. And again, they're just as meaningful as your ability to adhere to them. And then in terms of platforms, I think the way to succeed with a platform is to have a community of practice. And like the most successful platforms out there are using inner source, which means that you empower your developer teams to request the features that they need and to even contribute the features that they need. And there's a community of practice that arises to maintain the whole thing. So monetary funding for a platform has to come from high enough in the organization. So you're not talking about a product manager funding a platform, because then the product manager only wants the features that he wants for his product, not for the next product down the line, right? So you need to go high enough up to be able to see the interests of the collective. And then monetary funding is necessary but insufficient, because in addition to that, you need that community of practice, right? So commons in the scope economy only succeed when a governing community arises. So if you have open source and you have no community around it, you don't have open source anymore, right? And this is a problem because it's hard to have a community, but we cannot succeed in these areas long term if the community isn't fostered. And that, in my opinion, also has another implication for having the need for executive coalition for all of these concerns. Because if you're funding it from very low in the organization and you have the sponsorship from very low in the organization, you're not able to then continuously invest in those areas of practice. So I'm going to kind of leave you with this. The scope economy emerges from an ongoing negotiation between selfish interests in favor of the collective. And all of these things that involve essentially technical excellence, different aspects of technical excellence, live in the scope economy. And all of them can only be funded if you have the adequate level of funding and sponsorship and community investment to see the interests of the collective as the goal and not a particular engineering team. So that's about my talk. And I hope we get to continue this conversation. And I'm somehow on time. Did I confuse you all?
Thank you, Sasha. We still have like about time for like one question or so, but is there? Sure.
Thanks for the wonderful talk, very insightful. One of the challenges, at least personally, I've faced is a lot of organizations talk about technical excellence, but what it takes in terms of to actually create a culture and how to upskill people so that they can exhibit the technical excellence is something that is very little talked about. So any insights you have?
So I think that pertains to another topic that near dear to my heart, which is learning, personal learning and organizational learning. And so the problem with learning is that learning requires failure. Like when you learn a new thing, you're essentially not good at the thing until you are, right? And we don't like to fail, especially we don't like to fail publicly. So it's difficult to foster a culture and organization where people are not afraid of learning and not trying to prove themselves at all times to be already excellent. I think, some ways you can think of it as like that community of practice and people sort of essentially having common learning experiences, trying to like even hackathons or something like that, but like fostering the culture where people can learn new things in sort of public, and fostering the culture where when you are excited about something, you can bring that insight, you can talk about this insight, you can sort of have this, I don't know, brown bag lunches or whatever, right? Not easy either.
Okay, so that would be the time. So from 6 p.m. we'll have networking. So I guess you'll be at the networking as well.
Yeah. So I know this was a lot. I would love to talk about this. I would love to see if this was helpful, if this was consumable, and if you have ideas that I can improve this, or if I can help you improve whatever situation you're in. Thank you.